every single user had a sensor on the wall, and it still was chaos. But there was, at some point after, they real quietly disconnected the control system, and we had a standard thermostat on the wall for a few years that people were still pushing their little individual sensor that they thought was doing something, and it was never hooked up.
All right, welcome to the Blueprint Tour, episode 15, the last episode with Josh Krider from Howell. Been known him for a while. We are Permit Zip, trying to make access to small project engineering easy. Check out the website. We got an instant quote. You can get that price for your MEP in no time at all. We are at a sports park today at Josh himself. This is our last episode on coordination. We're mechanical engineers, and coordination is a funny word. Look at an architectural set, for example. I'm like, man, this set I can barely follow, but I have no clue what they have agreed to provide for services. And so when you go for cheap on the design side, that leaves a lot of holes and gaps and exposes everybody to more risk. And then it can turn into this like, okay, well, what's going on thing. So we thought it'd be cool to ask you questions about it from your perspective, because a lot of the way we engineer now is influenced by your advice. We've actually mentioned your name a few times on the podcast to other people, being like, we really like working with Josh and Ben Matthews from Metro, but each side of the trade representing the brightest ideas and thinkers, most expertise that we've worked with. So we really appreciate you coming. Coordination to you on a design build project. When you're taking on the design responsibility, what does that look like?
I will say that I think the challenges that we run into on a design build project are the same issues that you guys do. And it's being able to look at the drawings and know what's not shown in the drawings. That's going to be a challenge. And so it's the bottom of structure. It's how big are the openings through the bar joists. It's this ceiling that they show, what it actually looks like and how it's built. The challenges I think that we see are all of those things. I think the only big difference between when we're doing a plan and spec job and doing a design build is that, you know, the mistakes are ours, and we're a little bit more, we look for those challenges on the design side up front. We know stuff that we see all the time that we run into on plan and spec jobs, and we're trying to avoid it. One of the things that I think that you and I've talked about recently is just looking at how much space is above a ceiling, and whether the ductwork, you know, just how we size the ductwork to give us enough margin of error to make sure it fits.
Yeah, we talked a lot about that, especially with architects who we love the architects, but they never give us any space in the building.
Yeah.
and then it becomes, well, you didn't coordinate your ductwork. And I always ask the question, well, did you coordinate the ceiling? You know, you don't have to have a 15-foot tall ceiling with 2 inches of plenum space. You can have a 9-foot. We saw a project where there was literally a 10.5-foot ceiling in an office, a single person office. I'm like, is it really necessary to go like that? I mean, I need to put an air conditioner up here. So how's that going to fit? I mean, I could tell you the dimensions, but then those construction tolerances being so tight is always going to come back to me not seeing whatever sprinkler pipe was also in there, or the depth of the troffer light itself and all these other things. And I've, I guess maybe call me grumpy old man in my old age, be like, I'm not going to, I won't even draw it. If I don't got enough construction tolerance, that kind of thing, just because it's going to be a nightmare for everybody. It has to be predictable to price, which is one thing we're really keying in on.
Yeah.
That pricing, if we can think about what we're drawing as something that could easily be priced, then it should work out for everybody. And one of the examples, we got a project, what is it? We don't know exactly where the electrical service may be going, and we couldn't get the information we needed. I'm curious your perspective on this. I was like, we're talking about it. Like, what if we just told the contractor on the drawings, just put $15,000 right there for the question mark we don't know. Talk to the owner and be like, we don't know exactly how much it's going to cost, whether or not we know it goes here or here. We know it goes somewhere. But that way, when we say, investigate it for us, but put 15 grand over here to the side in the project, and we'll try to make it work in 15 grand. At least everybody pricing it has, okay, well, it's all a question. We all are going to call it $15,000. Is that, how would you approach it? You know?
Yeah, so we see projects that have allowances called for in them, and it's a nice way of putting a placeholder in to make sure everybody's working off of the same, you know, playing field in terms of pricing. And so I think that's a reasonable thing to do, is to say, hey, you need to set an allowance aside for this item, and we'll figure it out later.
Yeah, because that's tough. I mean, design bid, or you call it spec. Would you call it spec?
Plan and spec is when we receive a set of drawings that's already been designed.
Yeah, walk us through that real quick for people listening, what you mean by the two perspectives when you look at it.
So we have two types of work that we get involved with. Well, there's probably three types. And so you've got plan and spec, we've got design build, and then we have design assist. And so the three of those, design assist is great. And so design assist, we're talking to the engineer, we're working through, as they're designing it, we're doing budgets often. And so it helps for the engineer of record to land on where the owner's budget's at for mechanical system. And so as they're designing it, we're also doing like peer review on the design, and we're saying, hey, we don't think that this is buildable, or we don't think this is a great way to put this together. And here's how we would suggest it. And then you end up getting to the end of it. And typically, once we hit about 50% drawings, we're able to land our price is really close to where it'll be at 100% drawings. And so it's a really great way to hone in, but also to catch like some budget busters early. And so that's design assist. And then if you go to the other side of the spectrum, is you go the whole way to one side is plan and spec, where we receive specs and design engineer drawings, and we're just following the instructions. And then the opposite side of that is design build, where we just get an architectural drawing, and we talk to the owner, and we design a system that's around what their requirements are or expectations.
What was this one?
This was plan and spec.
Okay.
Yeah.
That makes sense. I think municipality stuff often goes that way, right?
Yeah, because since it was competitively bid, there was the drawings were delivered, pretty much complete. They were maybe 90% is what we worked off of. Yeah.
What's your preference? I mean, maybe the answer is it depends, but of all those three,
we would say we probably like to split it up between the three. Yeah. Design build takes a lot more work. There's a little bit more risk on us. Yeah. We like design assist, but it's probably about the same amount of work as design build. Just the risk is off of us. And then plan and spec's good, but we're trying to build it to what the engineer was expecting, And so they all have like but we're probably 60% plan and spec, and the other 40 is the other two.
We have a lot of feedback that to summarize it in the vibe of damn engineers, basically, that we're trying to work through with the podcast and just talk to people about our perspectives. And we one day we were on site with Jacob, an architect, and we talked to an electrician, and as soon as he found out I was an engineer, he's like, I hate you engineers, and started talking about it. And one thing he said was, well, you have your 4-year degrees and you just think you're better than everybody. I know you have a degree as well, right? Bachelor's in, what was it?
Economics and management.
Okay. Yeah. Well, yeah.
So I started out as a mechanical engineer. And halfway through college, I switched.
Okay. And then you ended up becoming a mechanical engineer.
Yeah, that's right.
So, for you, and you have the degree too, and that's just, I think, I've never thought to myself disparagingly about trades myself, because I really appreciate the input and the insights from somebody who's willing to help think about it and knows that they're stronger in the construction means and methods. And I'd rather know sooner than later that my idea is not going to be constructible. But I think that the ego of the engineer ends up getting in the way often to be able to accept that. But then also that perspective of that guy saying, hey, well, you just think you're better than everybody is either an insecurity on that side, and or the engineers do come across that way. We just don't have a clue because we're not the most socially gifted folks. What's it like, on your side, on the trade side?
Yeah, so there's a lot of different personalities you'll run into, within the field and the trades and general contractors as well as engineers, and I think that probably the comment of that you engineers have your degrees but don't know what you're doing or something like that is based on some of the engineers that they've run into, because we definitely run into guys that they're like, hey, you have all this experience, but you're talking about a contractor. Yeah. But but I know best. And so we get that. And we also get lots of probably more engineers that say, hey, tell me what your ideal solution is here. And I'll talk to my colleagues and we'll see if we agree. And the guys I think that are open to just sort of having this discussion is what we prefer.
Yeah.
And there's probably the majority of engineers and architects are more open to sort of this discussion of, hey, how do we both get what we want kind of thing.
You talk about a design assist. I would imagine no matter what project you're on, you behave as a design assist. I know that from personal experience.
Yeah. Mm-hmm.
But in an official design assist, what does that structure look like? You have like fees for consulting with the engineers early on?
So there's some design assist will have some fee that's associated with it. But what our ideal situation is that we have an agreement that the project is ours.
Yeah.
And so we're working towards saying, hey, we just want to design or help design this building to be, a really great system. And so there's certain projects that we really target that we want to be a part of design assist, and it's sort of built into our overhead that if we're going to spend a lot of time peer reviewing and giving recommendations and sometimes selections and sometimes some light design, as long as we make sense of it in the budget of our job, that's the direction we try to go.
Yeah, and you say it's about the same amount of effort as design build, I guess. In design build, I guess you would usually just hire the engineer directly, or if you don't need a stamp drawing, you do in-house kind of drawings for permit.
Yeah, so all of our design build, we're doing the complete design in-house, and then either we'll seal it with our master license, or if we need an engineer seal, we'll hire that out.
Gotcha.
So an engineer will review it and then stamp it.
Yeah, I mean, design assist is our favorite. I try to advocate for it early on. I have to ask this question. So if you could imagine what coordination or what the roles of the engineer was and the mechanical contractor as a Venn diagram, where do things overlap for you, and where would you ideally see the focus be for the trade contractor and the focus be for the engineer that are like exclusive?
We expect that when we receive a set of drawings that the capacities are right, that the overall scheme of the system's right as to how it's going to operate. When we receive a set of drawings, we'll review it for trying to catch where there's coordination issues and stuff like that.
Yeah.
But we're not checking capacities. We're not checking duct sizes to a large degree either. Mm-hmm. And we're not checking sort of like the overall scheme of how the system works with all the other parts that are in the system. And so that was where we would look at the engineer and expect that side of it's solid. Mm-hmm. But the coordination with lights or coordination with other trades, even some of the building structures, we think that falls on us to look at. And so when you talk about coordination, there's a bunch of different terms in construction: coordination drawings, or BIM drawings, or shop drawings, all these different things. And we see what we try to recommend, and we try to do on all of our projects, is that where we are looking to do coordination is actually out in the field. And so we're doing field measurements as opposed to, because even when you're doing coordination drawings, or you're doing BIM, or you're doing shop drawings, you still are doing the same thing we did in plan or in a design build, where we're trying to figure out what the system looks like before it's actually built. And so to go out and field measure and see some of these things is really, we think, is the most it's the most efficient. It's also the most accurate way of how we do our work. So.
And that works in a world where we as engineers are better at fighting for construction tolerance. They give you the ability to have things less likely to go just completely. It's one thing to say, well, I want coordination drawings and these little coordinations are things I want you to handle. It's another to say literally not a single duct on the plan is going to work. Mm-hmm. I mean, And so there's that Venn diagram where there is this portion where we have to at least fight hard enough to be able to make a quick duct size and not have to be thinking about every single hanger that's required to make this work. And that's where I think permit zip has improved and has been our biggest failure. We've allowed ourselves as engineers to be constrained too tightly into spaces, and then it just looks bad on us.
Yeah.
And it's just no matter how we shake it out, what we ask for on the spec, and that's what we really want to fight for. Electrical rooms are probably similar.
Yeah, same deal. We start by backing ourselves into a corner, like because the architect will ask, "Is this enough space?" And for the longest time, we'd be like, yeah, this should be enough space."
Yeah, we'll make it work.
They're really just asking genuinely, "Is this enough space?" And sometimes the answer to that question is no, it's not enough space because they don't know any better.
And it's a negotiation. And I try to tell the team to train yourself, steel yourselves for starting the negotiation with as much as you can ask for. So architects, I want you to plug your ears. But, get as much as you can because you're going to be asked, can I get less? Can you work with less?
Yeah.
So if you start with the edge of what you think can work, you're going to be pushed and pressured to make even less. So whatever you think it is, add, 25%, some number that just makes you feel comfortable that no matter what it is, because we know what we spec is rarely actually purchased because it might be long lead time or carriers here and we got this or that. And who knows what the form factor of the case for this equipment actually will be.
Yeah.
And the duct, we don't know the details of how big a flange may be or how to mount this or the sloping of a grease duct or whatever, which we're looking at on a different project. And so just ask for more and just pretend like there's no option. Again, I hope no architects listening are giving away the secret.
It really is the best way to do it, though. I mean, because it's the answer that maybe they want in that moment, but 6 months from now, when it's actually framed up or built up and there's a problem, we would have started with a 2 foot less tall ceiling or whatever it is.
Capacities, I do agree 100%. That should be on the engineer to do good consulting to understand what that means, whether or not you might have the capacity to remove moisture to within a specific standard deviation is important. That's the secret one that people don't know when they use the word, we call it a cuss word, value engineering. I don't like the idea that people are being persuaded that you can get something for cheaper with the same features. And then we get put in a difficult situation. I would say that I would trust if you said that it was value engineering, you specifically, Josh Krider, I would trust it because exactly like a damper system or this or that you can genuinely make work with the same features. But what we'll see people do is, hey, instead of this DOAS for makeup air, let's just do untempered completely. It'll be a lot cheaper. This should be the exact same functionality.
Or that one project somebody offered to use just a fan.
Oh, yeah. Somebody was like, well, instead of DOAS for ventilation, let's just, could we just put fans in the space? I'm like, no. That's not going to do the same thing. I know it's cheaper. So we call it input engineering now. We used to call it devalue engineering, but then I don't like that. It's got a negative connotation. I think it's about managing inputs because if you keep giving me the same inputs, I'm going to still calculate your same outputs. If your inputs are this is your expectation of comfort and you want this assembly space and it needs to be a hookah bar, I'm going to give you the tonnage will be the same every single time if those are your inputs. So which of these do you need to change? We've had one recently. It was a great experience where I started a conversation that way. It's 2 floors of smoking. I'm like, do you know how much that's going to cost to ventilate? You can't have chosen a higher category of ventilation. And so when the numbers came through, everybody's like freaking out. I had like 3 captive air Paragon units on there to deal with all of the, and there was a commercial kitchen as well. So on top of that. And so we've input engineered it. Now there's less smoking in the programming. And we figured out some natural ventilation tricks we could play on the upstairs, and we're adding this thing in the ceiling. So those are the inputs that are changing. How does that work how do you approach that when you need to accomplish, somebody's asking you for something and you know it's going to be out here and you need to get them into a different expectation?
Yeah, I think, well, I'll say that, you describing this hookah bar, there's certain types of projects that we won't design build. And I think you hit on like a couple of them in one statement there, because commercial kitchens are tough. They're really tough, and we see some of the most experienced engineers not be able to deliver the comfort that the client's looking for in commercial kitchens. And a lot of it's about trying to balance how much money it's going to cost. And and so we've seen that as a challenge. And smoking bars are really hard because of the outside air rate, and also because of the smoke is terrible for the equipment. And so you don't want to recirculate any through the equipment because it'll destroy it. And so there's a handful of projects, but often, well, you guys may have this luxury. Often we have the luxury when projects are brought to us that want to be design build. We have the opportunity to say no because it's too tricky.
Yeah.
And typically we're turning around and recommending they call a consulting engineer that has this expertise. And so there was an ice rink arena that was brought to us at some point recently, and those are tricky. And I don't have experience with doing ice rinks here in Central Virginia, and so it was just where you need to go out and you need to find a consulting engineer that's done these before successfully, and so. But if we have, I think if you have, we'll have clients who come to us that have unreasonable expectations or just interesting requests, and as you talk through with them, what the cost is going to be with it, and if that's a concern to them, and if it is a concern, they often will sort of adjust what they're thinking. And I think that's one of the angles that we have the ability. Often that as consulting engineers, you guys don't, is to have sort of a handle on what things are going to cost, and to say, that I want this 100% outside air unit to do a sports complex. It's wow, that's a giant piece of equipment. Is your structure going to hold that? The power that's required with it's going to be massive. And just all these different things that all drives back to cost. I think is some of like the value that we often bring to the discussion, So.
What is on here? What kind of units?
So this is the train rooftop units. There's probably maybe 700 tons of package equipment.
How many square feet?
What's that?
How many total square feet?
I don't know.
Oh, yeah.
I should know, but I don't. So the gymnasium's got 16 35-ton package units.
Wow.
We've got a bunch of energy recovery, fully conditioned energy recovery that's handling locker rooms and bathrooms. Trying to think, there's a lot of equipment, and so this competition side has got its own. Let's see, so we've got 8 units serving the other half of the gym, and 8 doing just this little section. So the capacity is probably under 100 square feet a ton to cover the full occupant load when it's filled up.
What's the most expensive thing to deal with in HVAC?
In terms of
in terms of somebody has a project, they have some specific inputs that are going to ratchet your pricing up if they want it done right. What are those kind of inputs that you see just driving cost way up on?
Yeah, so high occupancy, of course, is one of the really quick things that'll drive cost up quick.
Yeah.
The type of system they're wanting, VRF is a big, it's a desired system right now, and so when you have VRF, you should have dedicated outside air, and so when we hear people that come to us and want a VRF system, it quickly goes to a budget discussion.
Yeah.
Because of how expensive. VRF is amazing. The operating costs are low, the comfort's high, but the expense is high too. And so probably the occupancy, which drives outside air and drives our loads, and then the type of system are the two big things that really quickly start to help us to know it's going to be an expensive project.
VRF, okay, so walk us through that. So VRF requires DOAS. Can you kind of go over what that means for folks?
Yep. So VRF is variable refrigerant flow. It's taken typically a single outdoor unit, condenser that pumps refrigerant to a whole bunch of air handlers, individual air handlers. And so it provides the ability to heat and cool a lot of different spaces, with all those spaces having their own heating and cooling controls, their own thermostat. The other thing that VRF does that's really interesting is that in commercial buildings, I may have a space that needs cooling, and the space beside it needs heating. And it may be because of the loads, it may be because of the exposure. One's on outside wall, one's on in an interior space. And so VRF has the ability to take heat from one space and deliver it to another. So the heat that I'm extracting out of this room to cool it can be dumped into the room beside that needs heating. So it's a really efficient, it's a really neat technology.
Yeah.
The downside to VRF is some of the limitations is that it's it doesn't dehumidify as well as some of our conventional equipment. And so as you're bringing in fresh air into a VRF system, if you get very high amount of fresh air needed coming through a system, it should be pre-treated before it gets there. And so that's where a dedicated outside air system takes outside air, it dries it, and then delivers it into either into the piece of equipment or into the room at like a neutral temperature. And so it's helps to keep mainly the humidity under control in a building, which is important here in Central Virginia.
Yeah, humidity is similar to like imaginary numbers in math or reactive power. And it's like this imaginary load that nobody understands. They don't quite feel it. It's not as intuitive to feel as just the sensible side of things. It's really hard to consult with people on what that means to the cost. And so what are your strategies when you're trying to walk people through do you get into the technical? I mean, to me, I'm trying to find a way to talk through people about why it's problematic to go straight conventional or VRF, even worse on the sensible heat ratio. Like, what kind of tactics do you use to walk people through what the problem is?
Yeah. So when I'm looking at a particular space and looking at different types of systems, we're making a determination to say if they want to go VRF, we're only providing it with DOAS. And
that's a good idea.
If it needs it. And so the only time the VRF doesn't need DOAS is if I have spaces that have a low outside air load and a low, latent load on them, low humidity load.
Yeah.
I'm okay to pipe it in straight into the piece of equipment, not use a DOAS unit. But you just got to be real careful about doing that. And so as I'm looking at different spaces and through our load calculation, we can sort of see what the humidity load is going to be. And make that call, but we don't give them an option that if they're going to go VRF and we need DOAS, they're getting it. And then it's just whether you can afford it or not.
Yeah, I like that. For y'all that may have missed it, he very subtly used the word humidity in place of the word latent. But when you do hear the word latent loads from a nerd like me, what we're talking about is the humidity and the ability to control it. So HVAC systems have these like two main categories. It's the comfortable part of your life that you feel immediately, the cold air, and then that imaginary humidity thing that costs a lot of money to deal with, a ton, no pun intended.
Real knee slapper.
That's
right. So that's where the tonnage comes from. That's where the square foot per ton comes from. We've actually been recently taking the ventilation tables on the IMC chapter 4, whatever it is, and converting them to square foot per ton to say, this is how much these categories will cost you. And I basically get the square foot per CFM and then just give a DOAS rough 200 CFM per ton to just give them a number just to communicate how expensive each category is to help drive in. That's how much this much of the conference room will cost you, or smoking area, 65 square foot per ton of DOAS. And he was like, what did you say? I was like, yeah, that's how expensive it is to have that space. So let's think about what can we do.
Yeah.
I'm glad you brought up the recirculation of air too. I'll have to discuss that because of how might that destroy the equipment. What does that do to the equipment?
Yeah. So, pulling smoke laden air through a piece of equipment is very bad, and so like I would in a smoking lounge or a bar, if I were designing it, we would do 100% outside air and we do 100% exhaust, and so that I wouldn't bring anything through the piece of equipment because of the tar and whatever else is in the air would destroy the equipment, not just your evaporator coil that the air is going through, but the blowers and anything else that's in the airstream just gets.
Are there any charcoal filters or anything that maybe could help mitigate that? Or
there's smoke eaters and there's different technologies that help take smoke out of the air. I don't think there's anything though that really captures everything going through a piece of equipment.
I like what you said though about having a standard that you will expect if somebody wants to do it, and then just saying, if we can't do that, then respectfully, I can't do the project. We may need to approach that for just our engineering too. When somebody comes and we know it's going to be an expensive design, start there. But we're going to be unwilling to stamp specific kinds of things, even if they're not illegal, because it's just going to lead to you being angry and thinking it's our fault if you had to go the cheaper route. And I always tell people, I'm not in the business of forcing you to spend money, and I do hate seeing people spend money when they shouldn't on things.
I agree.
Like we had a request to do a change recently on a drawing, and it was just moving a pipe just a few inches. And I'm like, you could pay me, but I really am not going to feel good about sending this $500 invoice.
Yeah.
If you just ask RFI, I'll answer it. Probably forget to even bill a thing.
Yeah, that's right.
Which one do you want to go? I don't want to bill for that kind of task. I know that this is a thing that is, first of all, we haven't even gone to construction or selected the contractor yet, so it's going to change at some point.
Yeah,
let's change it then. And they worked it through. So that's kind of our version of not wanting to see money spent when unnecessarily. But I mean, shoot, yeah, you're right. One way to just address it is just not do it. It's going to require this, and that's how much it's going to cost. Otherwise, we wouldn't want to install that for you.
Yeah,
it's like seeing money wasted.
Well, I think a contractor's job is often to protect the client from themselves. Because often they just don't know what they're asking for, and so they, in fact, there's a project we're doing of you guys is that right now that the client want us to delete temperature and humidity sensors off the wall that are feeding a captive air unit, and the piece of equipment has the ability to run without these temperature sensors, but they have a really important function. And this was this morning we were talking about this.
Oh, really?
And
no kidding.
And so we got direction from I gather it's from the GC or from the owner to the general contractor, and general contractor to our tech on site. Hey, the client said just that they don't want these temperature sensors, and again, the piece of equipment has the ability to run without them.
Yeah.
It's got onboard temperature sensors, but we're not doing that. We're not deleting the temperature sensors on the wall because they have a really important job to do. Comfort cooling,
Yeah.
And
because that's that kind of system on that project. It's a comfort cooling DOAS hybrid thing where we're discharging 55 versus neutral temp.
That's right.
Well, that's what we were talking about before the show started, was that a lot of times they'll ask the question, and our biggest flaw on the engineering side is we'll go straight to figuring out if it can be done. Hey, can we remove the temperature sensors? We start immediately trying to solve that question we were asked instead of asking the client, is this even something we should be answering right now? Is it worth going down this road? Why do you want to remove these? It might be some just random reason that's not that important. It's like, no, you should probably keep it. It's like, okay. But in the past, we'd spend a week or two trying to figure out how they could get rid of it instead of asking or telling them, you don't really need to get rid of it. You need to keep it.
Yeah. Yeah, and so our job, again, this is going back and just saying to protect the client from themselves and saying, no, we can't do that.
Yeah.
No, we're not taking them off the job. These have a really important job. You need to trust us on this. And
is it a lead time thing or a cost thing?
I think it's aesthetics.
Oh,
yeah. Worse.
Well, yeah. Very good. Thank you. Good looking out, Josh. As always, like working with this man. Ben and you are the top-notch brains. I always Ben is a licensed electrician, but not a licensed engineer. But I always say that he's still the smartest engineer I know.
Yeah, he's good. Yeah.
Same with you.
Yeah. I think that often what makes and Metro's similar to us, that they do a lot of work, and so as we have the opportunity to see engineers work from all over the country, because we're often on 50 or 60 projects that, like right now, we're on about 50 projects concurrent, and
wow.
And so we're seeing all of these designs of engineers from all over the country, and you get a really good just a sampling of all these different ways that different engineers do things, because there's a lot of differences of how we engineer things here in Central Virginia than out in the Midwest and out on the West Coast, and so seeing all these different engineers and seeing different products that they're using that we don't use in our market, that they're specifying.
What kind of example? I mean, you don't have to give a specific project, but what kind of equipment do you see?
Well, like we've got destratification fans in here, and for destratification fans didn't come into our market until probably about 6 or 10 years ago.
Yeah.
And we started seeing them in grocery stores, and it may have been Walmart was coming into this market, and they were using destratification fans, and they were pretty new technology, at least for us. We hadn't seen them before, and now you're seeing them everywhere.
Did you got like air pairs? I don't see any.
I think I see one right
Yeah,
there.
one's right here. They blend right in because they match the color of the structure and the bar joists. And so, and the interesting thing about these is just talking about destratification is that they have a temperature sensor up high and one down low.
Yeah.
And when they see a greater than 2 degree difference, they come on. They come on at low speed, and they start ramping up as the temperature difference gets greater. And so that's like one of the things that we saw that came into our market from, I think, outside of, like, it wasn't brought to us by vendors. It was brought to us on drawings and sort of pushed us that, hey, this is an interesting.
Yeah, bipolar ionization also, was that another thing? Because I know you brought that to us and mentioned in the mechanical code that's a way to get ventilation rates lower.
Yeah. So we were doing bipolar ionization like probably 15 years ago, and it was we were using it then for the IAQP path in the ventilation code to reduce our outside air. And then when COVID hit, it was, pretty quickly, literature started coming out on how bipolar ionization had some positive benefits for viruses and that kind of thing. And I don't remember how I'm not sure how we started into bipolar ionization. I don't quite remember, but that was brought to us, I think, by one of our vendors, in providing us the engineering calculation on showing us how we could reduce our outside air load.
Yeah, we still use that spreadsheet.
Right. Yeah.
So if you're listening and all those words don't make sense to you, basically bipolar ionization allows you to calculate a different method for demonstrating the indoor air quality IAQ is what you just heard. And so that allows you to reduce ventilation rates, and the real cost to ventilation is, I would argue, is the moisture removal process needed for the transition. The killers are the 65-degree rainy days, where you may not have any sort of load going on, so you're not dehumidifying, but you have to ventilate, and you're bringing this air that doesn't kick on. You need a dehumidification process, and that's the price that happens. So you can reduce the cost of that tonnage by proving you can get away with less outside air and still remove contaminants in the air. So, really good technology. It's also legal. I went down the road for the smoking thing, seeing like, is there a smoke eater that has a similar spreadsheet I could use somewhere, and I couldn't find that. So we went a different direction. But yeah, that's one of those things you've brought to us that has changed everything about how we engineer.
Yeah, it's amazing. To be and from a user standpoint. So I've bipolar ionization in my house, and so we started really promoting it when COVID showed up, and I put it in my home because we were promoting it to our residential customers. So Howell's does commercial and residential, and which is also some of I think probably some of what makes us good commercially. It's because of our residential experience and some of the trickiness of residential heating and air conditioning in terms of providing comfort in a small building with a single system or a couple systems.
Interesting. Let's dive in on that. What do you mean? Yeah. So that is a good point. What do you mean by that?
Yeah. So in a home, while we're designing a system in a commercial building, often we're taking large spaces and they're having their own zones, and so they're really easy to make comfortable, or at least easier. Where in a house, you're taking a whole bunch of small rooms and you're putting a single system to serve a whole bunch of rooms and trying to keep them all within a degree or so of each other. And so it's it can be tricky. Some of the things that we do in commercial with making similar orientation and similar usage, their own zones, you can't do in residential. And so it can be just a little bit harder to bring an equal amount of comfort to a house.
Talk about expectation management too. Because that's an inexperienced, most home builder, people that are building their home are inexperienced in the construction process. So expectations, it's still expensive to them. There's no way to get HVAC for cheap, but it's like, okay, you can be as comfortable as you can afford. That's why I always say it. It's
Yeah.
like how your expectations have to be in line with the amount of dollars you have here.
Yeah.
But you're right. The residential market is generally like one air handler, maybe two if it's a large enough house, one
Yep.
for upstairs and downstairs, and then you have all of these large atrium spaces and this and that you
Yep.
deal with. So I would guess that's why some of the projects we worked with you, I'll see a zone damper on like a commercial application.
Yeah.
I struggle getting that right, because I don't know, it's tough. What are the tricks with getting that to work right? Zone dampering systems.
Yeah. Yeah. So, definitely there's a lot of, it's tricky in residential too, putting automatic zone dampers in. And so, commercially we, VAV systems are pretty easy to design. But putting a zoning system in a residential style zoning system in a commercial building is tricky. And so, I would say that the ones that we've designed, we try to use very few zone dampers. And so we may look at a remote zone that we think make it over cold because of where the thermostat's at. And we may make that its own remote zone that it throttles back. But putting a lot of zone dampers in is really where you get in trouble, I think, where we get in trouble.
Yeah, just keep it as simple as humanly possible and only use it when necessary. Because, the way that works is just it bypasses the return to maintain the pressure in the supply duct, right? And it's all low pressure the whole way through.
Yeah, but bypassing air is in a system can have some challenges too, because if your return air starts to get too cold in the cooling time, your compressor cycles off, or you can freeze the coil, and so there's a whole bunch of sort of unintended consequences that can happen.
58-degree air, so just going right back on the coil, and it just starts to get too cold.
Yeah.
It makes me nervous whenever I see that.
You guys are talking about cost. That seems like the third leg. You've got just overall capacity. You've got dealing with climate, like moisture, and then you got control. That's like the third.
Oh,
you
yeah,
can be as comfortable as you can afford. Is also, you could say you can control as much as you can afford.
Zoning, yeah, exactly, in the zones. And we were talking just before this that doesn't necessarily always having a bunch of zones doesn't always solve
That's right.
the problem.
Yeah, that was the discussion before the microphones turned on was how when I went to Howell's, we had this sophisticated control system that everybody had their own thermostat, and there's you could have two people in adjacent workstations, and one's hot and one's cold, and that is where the challenge of commercial HVAC does get exciting. Is to just trying to keep people that are comfortable at different temperatures from being too upset.
And then the placebo effect, I'm gonna start to recommend to people. Just say, listen, just give them a thermostat.
Yeah, that's right.
Don't wire it up.
Yeah. Put power to it so it has a display on it. Yeah.
That's so good.
Yeah.
Because it is. I would imagine that genuinely would work, because our minds do play tricks on us.
Yeah. Mm-hmm.
We are. We also were talking about before this how we could have an episode where we talk to different people in an office and ask them about the comfort level, and how we could show the exact same temperature is varying people will have opinions on how comfortable it is, and so that ends up being a problem that we are often having to try to walk through. It's an expectations thing. I would guess how much a percentage of your life goes to having conversations with people about what comfort expectations might need to be.
Oh, it's probably once a week we have a discussion with the client about just some of the ins and outs, and usually the people that are decision makers, we give them control. So sometimes that's thermostat placement is taking care of the people that that are influencers in a business, and so
Squeaky wheel.
Yeah, and that also happens in houses. That was one of the things that in my early years of residential, thermostats would go out in a common area in a hallway or something like that, and the industry started shifting away from that and saying, hey, we want to put it in the master bedroom or the primary bedroom, whatever you want to call it, as opposed to out in the hallway, because if we keep the people that are paying the mortgage happy, that's all that matters.
Yeah, that's so true.
Who cares about the temperature out in the hallway, you know?
Or the lease,
Yep.
the rent.
Yeah, that's right.
Whoever's the one that's writing that rent check every.
Yep. And so the same thing, commercial is just saying, hey, we need to put the control where it where it impacts the person that's the most important.
Yeah.
Got that smart thermostat. I just holler at my Alexa and say, Alexa, thermostat 68.
Yeah.
I mean, shoot, there's a lot of light commercial applications where Nest or something like that is genuinely a decent little thing. How about wireless thermostats? How easy is it to, in a commercial application, just buy those, or is that a headache?
You talking about that there's no wires going to it, or a Wi-Fi thermostat?
Wireless.
Okay.
Any sort of, so my mind is just saying we'll draw a thermostat if it was wireless. If it's easy enough and not too expensive to have that option, whether it's Wi-Fi or wireless, that it can be moved quickly. Is that an easy thing to find, or does that just make it a pain in the butt? Or
so we don't see that very often in commercial, mainly because of batteries, and have to replace batteries often. The only exception to that is that Trane has their new control systems wireless, and they've got some. I think because the thermostat does so little work, the battery lasts for 20 years, something like that. They publish it, and so. But it's just a wall sensor. We do install a lot of Wi-Fi thermostats, and so the difference is there's just a wire going to it that powers the thermostat, but you have the ability to access the display and set points and wirelessly, like through a phone app.
I guess like you said, I mean, if you have the thermostat there that's wired and needs power because the LCD screen has, you could still just put maybe a wireless sensor somewhere to just move around, like whatever it's sampling the temperature.
Yep. So we thermostat that we use a lot in commercial and residential is called Ecobee.
Yeah.
And it's a wired wall thermostat, but it's got wireless remote temperature sensors. And so those sensors can be moved around pretty easily. They've got like a watch battery in them, and we love them. And so they're the Ecobee it's a little bit different than a Nest on how its logic works, but we can take as many sensors as you want. In fact, we'd recommended Ecobee for this building for a couple reasons, but they ended up they wanted to go with a wired remote temperature sensor. But Ecobee will average as many sensors as you connect back to that one thermostat. It's got a motion sensor on board of the wireless wall sensors. That when I walk into a room, it recognizes motion, and it'll tell the system run off just that room if you want. And so it does a whole bunch of different really
it's
interesting
demand
things.
Control ventilation, basically.
Yeah, yeah, it's really interesting how it's a good residential and commercial thermostat.
Just so everybody knows, we don't get a kickback from Ecobee, but that is quite the endorsement. I sometimes do the same when I talk about Captive Air Outlet, because out of all the commercial kitchen ventilation system providers, they at least they provide a lot of support for it during the design phase, and they do their own, they'll do their startup and commissioning and just take care of it. Whereas, I won't say any other names, but some other vendors may just be like, hey, here's the fan, good luck. And where they take a lot more ownership from the very beginning to the end, at least from an engineer's perspective. Do you have any similar experience working with their products?
Yeah, they're great. Yeah, we do a lot of captive air work, and they support their products well.
And we are not sponsored by them, and I always have to say it because I talk so about them, but it's part of what you talk about. Commercial kitchen ventilation is a tricky one to get right, and to do it right just costs a lot of money. And then if you don't, I don't know, that DOAS that you're talking about, the Paragon unit, I mean, you just buy a set, turn it on, and they got the sequence stuff already sorted out. And if you do something different, then you can discharge to the plenum in front of the hood, and you can maybe temper it or not. But all that moisture is still going to sort of eke out. It's not all going to go into the hood, and then you have this load, and you put a little split system in there, and it's just going to be uncomfortable. Early on in that project, when we were consulting, all the constraints were too high. I just had to tell them, like, you're having me draw 3 perpendicular lines here. They wanted to be perfectly comfortable. They didn't want to see the unit. It couldn't be so many dollars, all this. And I was like, something's got to give. And chef's got to be willing to be uncomfortable, or you got to be willing to see this thing, or I don't know what to tell you. And then during the meeting, they literally told me, you need to stop saying that. Like they wanted me to just stop telling them that they were over constrained. Like try to say that to a structural engineer.
Yeah.
Like you can't build this without people falling through the bridge.
Right.
You need to stop telling me
Yeah.
that. I was like, whatever, you know. But I often feel that way. That's why I don't like the word value engineering, because I believe it's a little bit. And this is not to speak disparagingly about the process. It's there, but I think it with the wrong hands, it's like snake oil.
Mm-hmm.
You know, you're being persuaded that you can genuinely spend $100,000 less and have the exact same performance.
Mm-hmm.
So I like your approach, being like, just rather than go down that road, just say, we won't do that.
Yeah.
Set your own standard. That's good.
Yeah, agreed.
Let's see. We got other questions. Any interesting things on this particular project that would be cool to talk about for folks listening? I mean, you 700 tons of cooling. There's got to be something cool in there.
Yeah. So the some of the changes that we made on is something cool in that, right? Some of the changes that we made. You have a clap like
Can you please clap for me?
Yeah, there you go. Oh wait.
Thank you. That was good. I think there's a drum that goes. Yeah, there we
I
go.
remember which one it was too.
All right, sorry.
Yeah, that's right. So some of the changes that were made on this project, fabric duct was one of them. They had single wall spiral in the gymnasium, and so that was a concern of ours, was putting single wall spiral in a potentially high humidity area and at 40 feet up. So that was a change that was made to fabric duct, which I think was a really good one.
I have to ask you to explain why, because that's a really cool thing to talk about. The nerdy science behind why that would be a problem.
Yeah. So the when we're dumping cold air into ductwork, if it's not insulated, it has the potential to sweat if the indoor conditions are in a certain humidity level. And so as ductwork gets higher and higher up in a building, I think we talked about like a 14-foot roll or something like that, that we at one point you and I talked about. As ductwork gets up higher and higher in the ceiling, there's more of a chance of humidity hanging up high in a building, and so ductwork potentially could sweat. And so the impact of that in this building is that because we're 44 feet up, if they start to have an issue with sweating, to fix it would be just a tremendous cost. And so so that was one change that we made on the job. From a coordination standpoint, I think one of the reasons that I had mentioned to you about coming here was there was some coordination things that popped up that the engineer had the same challenges that everybody does, and he had shown ductwork up in the bar joists, and the bar joists ended up so the bar joist is, I think, a really good example of coordination on a project. Is that the construction drawings showed all this ductwork going in certain locations, and it matched up with the structural drawings. But when these bar joists were actually fabricated and the shop drawings came out on them, the openings were in different places. And so, and it wasn't the engineer's fault. For whatever reason, I don't know where at in the process, the bar joists looked different than what they did on the construction drawings. And so the location of where my lateral fabric duct lines go through the bar joists is different than what's on the construction drawings as a result of the bar joists being built differently. So that's an example of, we caught it early, and we knew that we thought there was going to be a challenge there, and so we never, we actually never even submitted on the fabric duct until there's final shop drawings out on the bar joists in the gym. But in here, the ductwork was shown to all be up in the bar joists, and the spiral wasn't a big deal, but this rectangular duct was.
Is that a return?
So this duct over here is going down to the first floor, and so this is like a 30
unit above.
Yeah, it's like a 30-ton unit that sits right above us. It drops in, and what you're only seeing is one of maybe 4 trunks. And so what they had shown was something that was giant, and it wouldn't fit up in the bar joists. And so we ended up doing a pretty big rework on that to keep everything up in the bar joists. And I'm not sure how. Well, maybe there was, often there's things structurally that we don't know about that maybe the structural engineer had shown a boxed out section of the bar joist and it didn't get fabricated that way.
Or as you're saying, the shops come out later, or a lot of the stuff could be delegated design from the structural standpoint. And so we have to trust that when somebody says you can get this much duct through it, we'll do it. It still reflects poorly on us when it doesn't work as the engineers, because it's like, well, you didn't coordinate your duct. And like,
yeah.
I mean, that's kind of partially true, but
well, I think I've mentioned to you that there's an architect that we work with a lot up north, and he's an older guy and been in the business a long time. And his comment to me is that it's the architect's job to coordinate all of his consultants. And it's really interesting. I know that's like probably scandalous, in the architectural world. Yeah, that's right. You'd love him. He and so he says that the structural works for him, MEP works for him, and it's his job to. And this is in the context of me sending him sketches and drawings and saying, hey, I don't know if this will work, but this is like an idea.
Yeah.
And he'll often say like, hey, it's my job to coordinate that. We, as an architect, know how everything to a large degree goes together. Mm-hmm. And he said, we'll just drop the ceiling, we'll build this, we'll do this, and it's a different approach.
Well, a little sneak peek into the season 2 that we'll be starting on next episode is design, and it's related to what we've uncovered through the coordination conversation, and that I think people don't understand. Engineers spend probably 80 or 90%, you do, but most don't, on the theoretical, invisible, imaginary stuff that nobody sees, the capacity selections that you mentioned.
Yep.
And how do we get to that point? It requires consulting, it requires code study. Do you need the ERV? And how much of this capacity do we need? Then the value engineering crossword shows up, and we have to walk through that. And we finally got the system working, the sequence, some of these things going out, and then we got to draw some ductwork. For us, it's not necessarily an afterthought. For some firms, it's more there, mostly because they get paid for it more than we do in the light commercial market. But for us, it's like, all right, ductwork, let's just put some stuff here. However, for that architect and for the builder of the ductwork, that's especially the builder, the fabricator, and the installer. That's most, I would guess, hours go into putting the ductwork in, right?
Oh, yeah.
On a job. So I don't know, just 80% of your hours maybe go into just getting the ductwork on, of course, depending on the job. But you got to crane the thing up, set it, get it out, right? And then ductwork, a couple controls while land the wires, and most of these things are plug and play. You turn it on, it rolls, unless it's VAV, and then you have maybe a controls contractor. So that's what we're going toward to talk on the next is we have Venn diagram. It's very theoretical over here, and it's the imaginary stuff. And engineers, I think, would do better to just say, more honestly, our weakness on the construction of means and methods, and not pretend that we know it as well as somebody whose entire career is getting it to work. That's why I love the design assist approach, because you know what's on the shelves, you know the lead time, you know the cost, you have great ideas. It's you specifically as Josh, but you also generally as the industry.
Yeah, I agree.
And what will work and what won't work. It'll look so obvious to somebody who does it every day. Whereas the engineers, like, probably is fine.
Yeah.
It's just it's a different universe. We just don't even see it. But I believe that a lot of the conflict and coordination is rooted in that perspective that is design. That the ductwork layout is what all that we do in design.
Yeah.
And it's a lot less. Yeah. It's a minority of our hours.
Yeah. I think that we for contractors that do design build work, they have I would say a higher appreciation for the consulting engineer's job, and also some of looking at drawings and saying, they show this or this or this, but that they didn't mean that. They didn't mean it quite that way. We need to do this, this, and this, and we do that often. We're just redlining things and saying, "Hey, we know that this is not." And so, for example, like when I do a design build, in my CAD program shows duct a certain way. And it doesn't mean I actually wanted it to have these features. It's my AutoCAD's drawn it that way, and I didn't catch it and edit it. And so our guys know, oh yeah, it's got a Howell's logo on it. It's our job. He didn't mean for all these nested elbows. He wants a radius elbow instead. And so we look at engineers, consulting engineers, or plan spec work, and we say, hey, we're looking at this, and we think it was probably like my nested elbow sort of scenario that they didn't mean for it to be this way, and so but it also gives us an appreciation for what you guys, some of the challenges that we run into on plan spec work is like, hey, these are the same things that we trip over too. Just refabricate that duct, and that's it. We're not trying to capture any kind of additional cost in this.
We see our drawings going straight to Vortex or some other fabricators, even if we've asked for shop drawings. I'm like, well, y'all, do you guys know what's happening right now? Like, please don't fabricate off of that. Let's talk, at least have a coordination meeting together so we can discuss how we've approached the design. One of the main discoveries from this podcast series for us is the importance of being at these kickoff meetings and building that trust early on with whether it's y'all or any other trade. Just say, hey, here's who we are. Here's how we approach the design. We focused all of our hours here, but we had a limited budget here, so that we can just be honest, disclose it as soon as possible. Like, we're willing to be on meetings to walk through or talk through, because a meeting for us could save us 20 hours of drafting and thousands of dollars of fabricated duct that has to be redone.
Well, whether you guys, particularly Permit Zip, likes it this way. We are not RFIing to say, hey, can we change the equal duct size to this, and this? We're redlining and we're making changes and resizing. So if you got 30 by 30 duct, we're resizing to equivalent and just rolling and not asking to be redrawn, not asking, not even asking for, hey, you okay with this? It's like, hey, it's not going to fit here. Talking to the field, send me a modification and I'll look at it. We're going to roll with it. Yeah. And 99% of consulting engineers are like, no problem. We're okay with that. Just make sure your red line drawings reflect all the duct changes so that everybody can see, just what you've done differently.
Yeah, there's very, very few situations where that does speak also to the engineer's primary focus, right? The main thing that I would get worried about with resizing ductwork would be for a larger VAV, like large horsepower fan or something like that. And I think engineers doing the medium pressure, high velocity stuff would be more careful with coordination on that because it does relate so much to the fan size. And so the wrong size fan could be extremely problematic. But otherwise, the fact that you're saying 99%, it kind of is indicative of that the engineer's mind is like, yeah, fine. Yeah. Rework it. I spent all my hours making sure I had this reheat, whatever in this area or whatever imaginary stuff that's never seen.
Sure.
And so that's interesting that how you say that. It makes me feel a little more sane.
Well, and I think that some of like the, that the consulting engineers, you don't know what the next consulting engineer or the next one is, allowing, in terms of latitude from a mechanical contractor. And there is a few that want everything to be RFI'd, but most of them are they get a pretty quick understanding of whether the mechanical contractor knows what they're doing or not. And, and in terms of shop drawings or coordination drawings, we see that having a discussion with the engineer early in the project and saying, hey, listen, we fabricate all this stuff ourselves. And so we're not going out to a Vortex and getting a truckload of ductwork made for the whole project on day one. We're fabricating as we go, as we're field measuring. And we would rather field measure than try to do the same thing you did and put together a shop drawing that we know is going to, 20% of it's not going to be right. And and as long as you're real clear and saying like, listen, we include in our job that we're going to have offsets, and we're going to have transitions, and we're going to have changes. Yeah, we include that. We're not billing you for this, but we also don't want to waste our time and yours with reviewing shop drawings that we both know they're the same accuracy as yours are.
I love that you said that. I mean, that's even you from the most qualified person to be creating them knows that all that work may not even be worth it. It'll be only 20% of it, or 20% of it's not going to be right. I think is what you said. And because it's like, how much time do you want to spend perfecting a drawing versus just getting there and fabricating the thing?
Yeah.
And that expectation of perfection is, I think, some people in the industry expect the engineer to have perfectly coordinated drawn ductwork. Yeah. And even if the person doing it saying, well, 20% is not going to be right, is saying that it's just not worth my mental energy and focus to get it 100% right.
Yeah.
I'd rather my guy just be measuring it and then bending that duct right there. Do you guys do it in the field, or do you just go off site? Okay. Yeah. I was wondering if it was like, if you brought like a podcast studio version of metal making to your site.
Because we just want it to be right. But in an 80-20 scenario, especially on a bid job, asking for coordination drawings is the only way we can ensure that it is right. But it's way better to have somebody that knows what they're doing, measure it in the field, and just do it piece by piece. Yeah.
So I mean, how that practically looks is you've got a guy that's a foreman that's that he's looking at the work he's doing next week, and he's field measuring where this duct's going to run and what obstacles are in the way, and he's turning in a takeoff for maybe a week's worth of work that's a week in front of him, and it gets fabricated. And I think that what you hear often in construction is that BIM, when you're doing 3D coordination drawings, that it speeds up the job. It does all these cost savings, and I think that where that is accurate, there's certain types of work that's accurate, and I don't think in the light and medium commercial world we're seeing those kind of savings with BIM, because where we see a stumbling block with BIM is that if one particular trade doesn't follow their BIM drawings, it doesn't matter.
Hang on, sprinkler.
Sprinkler. There you go.
I got love for the sprinkler. We'll be doing in the Derby, coming in Kentucky, talking to some fire safety folks. Drinking a bourbon.
Yeah, that's good.
They're at the Kentucky Derby is coming up soon. But yeah, sprinkler has a tendency to just show up randomly, and it makes us all be like, oh, you're just gonna go right there. Cool.
Yeah. I wasn't gonna do that.
Yeah. We can change that, but it's gonna be 6 weeks and $50,000.
Yeah, like okay, I guess we'll just move our ducts.
Yeah, that's right. Up and over. Yeah,
it happens so much. Like electrical, I always give Carter heck because I feel like electricals feeders on a multifam, for example. I don't know. Do y'all do multifam projects?
A little bit.
So you'll have this SC cable, this flexible kind of feeder, and there's 100 apartments, and they do have to go somewhere, and they end up being physically massive.
Yeah.
Like, you need a massive chase. I've seen people just destroy little concrete openings, just stuff these cables up. But we never got to draw. You don't got to ever draw that stuff.
We don't have to go anywhere. They know which unit they're supposed to go to.
Panels and like
it's wireless power.
Yeah.
Yeah, I wish I could do that. Just show my diffusers, and then the industry would be like, I guess we'll just figure out the ductwork.
No, we do get a pass on that.
We look at electrical drawings and just like, there's just there's the outlets going around. It's like, what kind of direction's that?
Oh man, I've done them all. I used to be on the electrical team. Now I'm on the mechanical team. I've done the plumbing too, and so I can say that the electrical, I do enjoy that part. Now they got plenty of nerdy stuff that they do got to stress about that we don't. But
yeah, like all the devices and every single light and receptacle and all that.
Yeah. And every single time we change our spec, they're like, oh, I guess I have to revise my drawings too.
Thanks, mechanical. I already stamped it, but I guess I'll open Revit back up and fix it.
Yeah, water heater changes, electricals just gets to tack on that free extra 3 hours of revision just for fun to change that breaker size.
Appreciate it.
Yeah. That happens a lot. I guess we'll spec something and the HVAC final spec changes, of course, because of lead time or whatever the reason or price, and then suddenly that 70 amp breaker is a 90 amp breaker for the MOCP.
Yeah, Ben is great about that. Every single Metro submittal, he's got the red note already there. Is like coordinate with final HVAC submittals before releasing the breakers.
That's a good one. That's a good coordination question for you. How is that? For us engineers, it's like a little secret battle. We always just kind of like give each other heck. Like, you change your stuff back and forth. But you got a trade contractor that's not internal.
Yeah.
You got to chase down these breakers or change your spec. How do you handle that?
So the expectation is that the general contractor is, we work for the general contractor, that we're sending him our submittals, they go up the chain, they come to you guys, they back up the chain, back down to us, and that we're often telling the general contractor, hey, remember to send these to the electrician. But good electricians will, I mean, Metro and lots of other guys will either reach out to us directly and say, hey, can you send us your approved submittals, or hey, can you tell us what else changed from what was specified in terms of MOCP?
Yeah. You heard it. You heard it here. The two best trade minds in Richmond, man. I'm glad we got you. Ben is on here as well. We had him on here.
Yeah.
You'll have to watch that one. And before you guys were guests, I was always making mention to you. So I hope now the listeners kind of understand why that is, because you guys, you even know, but Metro is proactive on the coordination of that. And Ben is always very careful. Fire pumps, water heaters, HVAC equipment, to know that his breakers are just subject to change. And then there's other folks, that will just buy it and then be like, well, and then charge a change order for the breaker size.
Yeah.
It's like, man, you didn't, what? Be careful with that. Why'd you rough it in?
Yeah.
And I mean, I could understand maybe buying it for lead time reason, just swap the breaker out.
Sure.
If you got a 90 amp breaker in the shop, just put that in on that equipment. It's cheaper to get it ordered sometimes. But don't rough in the wire.
Yeah.
That's a whole other level. Unless it's after the submittal, if the submittal's been approved and then it changes it.
Yeah.
Yeah.
There's lots of, the different trade contractors definitely know, what plumbers and like for us, what plumbers and electricians are good and are really thorough about their job. And so they start to recommend each other. And so Metro is great. There's a bunch of like really good electricians that we work around. And then there's others that we don't care for, and it's a lot of, oftentimes it's just how thorough they are, and because our stuff does change, and a good electrician will make sure that we're communicating with them what we've got going on.
We'll wrap up soon because we're running out of time, but one question I wanted to ask you is, you work with a lot of engineers, you said, with all these different projects. What are some of the qualities that you appreciate most in an engineering firm, drawings, anything? Like what's the most appreciated?
So that's a big question. Definitely we like engineers that I have lots of engineers that'll call to and not even on jobs that we're doing design system, will call me just to say, hey, have you heard of this product? Or I've got this application. What have you guys seen that hasn't worked? And can you give me a budget on doing this versus this? And we like doing that stuff. It helps the projects when they come out. They're better, and so I think those are good qualities. That guys are. I think lots of engineers maybe don't know that they can reach out to a contractor that they trust and say, hey, what have you guys seen for this kind of thing, or have you heard of this piece of equipment? What's the industry say about it? Because oftentimes when we're substituting equipment from what's specified, it's because of not all cases, but lots of cases, because we don't like the piece of equipment that's being specified from a support standpoint or reliability. And so I think engineers, having more communication on the front end of things they're working on, we like. We like drawings that are easy to follow, and that's some are easier than others. Engineers that are willing to work with you. We encourage our project managers that anytime we're writing an RFI to write what we believe the best solution is.
Yeah. I like that.
Yeah. Yep. And I think that's a good I think that's a good standard for the industry, and I would say that engineers often should kick back and say, what is your requested solution to this? If there's not a solution given by the contractor, because often if we write an RFI and don't give a solution, and the engineer writes something back that's like, oh man, that's tough to do, or that's not going to work either. And it's sort of on us that we should have written a possible solution on the front end.
Engineers, listen up, because I like that advice. What is your requested solution on this? And just try to build the trust of, like, I'm wanting to hear how you want to approach this, so I can be the nerd to read the code and look for how to make that work. Because that is true. What happens is the engineer may not answer the RFI soon enough. And in that situation, yesterday is not soon enough. Everybody wants to answer, and then by the time you finally get one, it's just maybe another question, or it just makes it worse. And you're like,
Well, it also makes it easier too. You get this RFI and it has a solution on. You look at it and say, makes sense to me, and you hit, you respond, say approved, and it's just off your desk without having to try to reinvent the wheel.
I know that's from experience. That's how you operate. I've had a couple projects where you'd be like, hey, well, this is going to be difficult or whatever. What about, would you be cool with this little dehumidifier and put it this or that? And I'm like, well, shoot. I mean, that's better than my design.
That's where that relationship comes in too. Because with you and Josh or me and Ben or whoever, it's just like the trust is already there. So of course we do our due diligence and look at it, but it's a lot easier to say, I know that Ben or I know that Josh has looked at this and put some actual thought into it to feel more comfortable approving it.
What I think most contractors don't know is why we prefer design assist is so that we don't have to redesign it, because in a situation where it's not covered on the CA, that does end up costing money to change, and it can be perceived, well, Josh's idea is better, and it is. It's like 100% of the time. It's always been better. But I'll still charge sometimes to change, depending on the client or the relationship of the situation. And then they'll say, well, why are you charging? Because his idea is better. And I say, well, it is better, but it's still time. I mean, I would rather have had him, if it's $1,000 change, for example, to redesign it, I would rather have had that $1,000 have Josh early on in the design with me and pay him the money directly to have this be the solution from the get-go. And I think that Venn diagram image, I got to figure out a way to make that graphic. It's something I want to market outward to the industry and say, just play in this part. Let's lean into the strengths here. And where we overlap, that's great. But like, what are your strengths on this side and what are my strengths in here? If we can just focus on them and get better at what we're already good at and blend it through the process, then I think we'd have a lot more success in a lot of the construction jobs.
I agree.
I'll wrap up here.
That's great.
Josh, thank you so much. Thanks for that. We got a huge audience here tonight.
They're all out there on the court. You just can't see them.
Yeah, thanks so much for coming out, man. It's been a time inviting us here. Thanks to Enrico Sports Park for having us and hosting this. We'll get some B-roll footage of these cool things that y'all can see. Check out Howell's. What's the website?
HowellsAC.com.
HowellsAC.com. We'll put that up here too for y'all to check out. And if you ever want to talk to somebody who knows most in the industry about HVAC, make sure it's Josh Krider. All right, see you next time.